Hello everyone. So it is our next topic, first order linear differential equation. In my last lecture we have completed all the rules of integrating factor, and this is the last topic, or you can say this is the last rule of integrating factor, first order linear differential equation. So first of all we have to know what is first order linear differential equation, then we will discuss about the integrating factor and the solution of this differential equation. Okay, here the topic is first order linear differential equation. We know how to find out the order of any differential equation. So first order means in this differential equation you will get the term dy dx. Okay, you will get the term dy dx. This is first order. Now linear, what do you mean by linear? Linear means the degree of the differential equation must be 1. Okay, degree will be 1. So when degree is 1, so obviously all the equations, all the first order equations with more than 1 degree, that will be nonlinear. Also all the equations with no degree, that will be nonlinear. Okay, so linear means only degree 1. Okay, so first order linear differential equation. Let's take an example. Let's say dy dx plus y, this is equals to let's say x. Now this differential equation, is this equation first order linear differential equation? Obviously yes, because this is order 1 and the power of this dy dx is 1. So this is first order, first degree, that means first order linear equation. Okay, now it is possible that there are some coefficient with y. Let's say the coefficient is p, capital P, and this is x na. It may be x square, maybe e to the power x, anything. Okay, so that's why I am taking this is any arbitrary function of x. Okay, let's say this is capital Q. So here p is a function of x or any scalar number. Similarly q, this is function of x or any numerical value. Okay, so this equation dy dx plus py equals to q, this is called the general form of first order linear differential equation. Clear? This is the general form. Okay, now tell me, this equation, this general form, is this equation exact equation? So first of all let's convert this equation. So we can write dy plus py dx, this is equals to q dx, yes or no? Or you can write py minus q into dx plus dy, this is equals to 0. Okay, now in this equation what is m? M is equals to py minus q, and what is n? N is equals to 1. Condition is del m del y must be equals to del n del s. So what is del m del y? Del m del y is capital P, and what is del n del x? Del n del x is 0. Is it always necessary that P must be equals to 0? Not necessary. P may be non-zero. That's why in general this general form is non-exact. Okay, this general form is non-exact equation. Clear? So you can say that in general the general form of first order linear differential equation is non-exact equation. Clear? So obviously if this equation is non-exact equation, so obviously there must exist integrating factor. And here is the 6th rule of integrating factor. 6th rule for first order linear differential equation. Okay, so in this case what will be the integrating factor? if. This is equals to simple e to the power integration p dx. This is your p na. P means coefficient of y. Okay, so just you have to integrate e to the power integration p dx. Okay, and solution. What is the solution? Solution is very simple. Actually, in this equation, which one is dependent variable? Y. So dependent variable into integrating factor. Okay, this is equals to integration. Right hand side, what is right hand side? Q, na? Right hand side function of x, q. So q into integrating factor, and q is a function of x, so integration will be integration with respect to x plus integrating constant c. This is the solution formula of first order linear differential equation. Okay, so I am repeating the general form is dy dx plus py, this is equals to q, this is the general form. Second, integrating factor is e to the power integration p dx. And third, solution formula is dependent variable into integrating factor, this is equals to right hand side into integrating factor dx plus c. Clear? Let's try an example. Question: solve cos square x dy dx plus y, this is equals to tan x. This is the equation. Obviously, you can see this equation is not in general form. Yes or no? This equation is not in general form. So obviously, we have to convert this equation in general form. So solution. You can write given equation can be written as so we have to divide by cos square x because the general form is this one, dy dx plus py equals to q. So let's divide by cos square x. So this will be dy dx plus 1 by cos square, that means sec square x. So y sec square x, this is equals to tan x sec square x, or dy dx plus y sec square x, this is equals to, what is tan x into sec square x? Tan x means sin x by cos x, and sec square x means 1 by cos square x. Okay, let's take it as tan x into sec square. No need to simplify this part, just tan x into sec square x. Okay, let's delete this portion. Okay, so you are getting, okay, no need to calculation the second part, just this is the equation number, let's say this is equation number 1. Okay, now we can compare this equation with the general form. So what is our p? So comparing with dy dx plus py equals to q. So what is p? P is equals to sec square x, and what is q? Q is equals to tan x sec square x. Okay, so what will be the integrating factor? If equals to e to the power integration sec square x dx. And what is the integration of sec square x? Tan x. So this is equals to e to the power tan x. And I already have told you that when you are calculating integrating factor, no need to write the integrating constant. Okay, so just e to the power tan x. Now solution is what is the dependent variable? Y, na? So y into integrating factor e to the power tan x, this is equals to integration q into integrating factor. What is q? Q is tan x sec square x into integrating factor is e to the power tan x dx plus c. Okay, or y into e to the power tan x, this is equals to integration. Now you can solve this integration by taking z equals to tan x. Okay, so if I take z equals to tan x, so dz equals to sec square x dx. So you are getting z e to the power z, and sec squared x dx means dz plus c. Okay, or y e to the power tan x, this is equals to, now you have a formula that integration x e to the power x dx, this is equals to x minus 1 e to the power x. This is the formula. Here you have z e to the power z, so you can write z minus 1 e to the power z plus c. Yes or no? Okay, now put the value of z. So you are getting y e to the power tan x, this is equals to tan x minus 1 e to the power tan x plus c. Okay, and this is the solution. You can subtract by e to the power tan x, so this will be y is equals to tan x minus 1 plus c e to the power minus tan x, subtracting by e to the power tan x, and this is the required solution, which is the required solution. Okay, so this is very simple. Process is very simple. First you have to convert the given equation into the general form. This is the general form. Okay, then e to the power px, e to the power integration p dx, that will be your integrating factor, and the solution formula is this: y into integrating factor equals to integration q into integrating factor plus c. Okay, now let's try another problem. Question. Okay, before solving second problem, let me tell you something. Suppose we have an equation dx dy plus px equals to q. This is an equation. Tell me, this equation, is this equation first order linear equation? Obviously yes. Okay, but problem is, in this equation dependent variable is x and independent variable is y. Okay, so dx dy plus px equals to q, in this equation dependent variable is x and independent variable is y. So obviously what will be the integrating factor? If. In the previous case, the integrating factor was e to the power integration p dx. But in this case, here p and q, they are not function of x. Here p and q both are function of y or any scalar number. Okay, so integrating factor will be e to the power integration p dy. And what will be the solution? Same formula, dependent variable into integrating factor. Here dependent variable is x, so x into integrating factor. This is equals to integration right hand side into integrating factor. And here q is a function of y, so integration with respect to y plus c. Okay, so let's make two columns. Right hand side, first order linear differential equation in y. First order linear differential equation in y. That means in this case the dependent variable is y. And second case is first order linear differential equation in x. So in this case the dependent variable is y, and in this case the dependent variable is x. Okay, so first one. In first case, what is the general form? Dy dx plus py equals to q. And in this case, what is the general form? Dx dy plus px equals to q. Here p is a function of x only and q is a function of x only, but in this case p is a function of y only and q is a function of y only. Okay, number 2. In this case, what will be the integrating factor? E to the power integration p dx, because p is a function of x only. And in this case, what is the integrating factor? E to the power integration p dy, because here p is a function of y only. And number 3, in this case the solution is dependent variable y into integrating factor. This is equals to integration right hand side into integrating factor dx plus c. And in this case the solution will be x into integrating factor. This is equals to integration q into integrating factor dy plus c. Okay, I think the difference between the two types of first order linear differential equation is very clear. In first case dependent variable is y, in second case dependent variable is x, but nothing else. Okay, so let's solve another problem. Solve x plus y plus 1 dy dx, this is equals to 1. Here you can see this equation is not in first order linear differential equation form. This is not in y, this is not in x. So first we have to convert this equation. Okay, actually we can write dy dx, this is equals to 1 by x plus y plus 1, yes or no? But again this is not in general form, so let's convert it. Dx dy, this is equals to x plus y plus 1, we can write in this form. Now you can see that this is almost in first order linear differential equation form, but here in this case the dependent variable is x. So when dependent variable is x, you can see that the left hand side is x term, na px. So left hand side must contain the x term. So obviously in this case you have to take this x to left hand side. So dx dy minus x, this is equals to y plus 1. Now you can see that this is linear first order equation in x. So what will be the integrating? What is p? What is the value of p? Here p is equals to minus 1, because this is minus x. So p is equals to minus 1. And what is q? Q is equals to y plus 1. Okay, so what is integrating factor? E to the power integration minus dy. Okay, because this is the formula, integration p dy. So e to the power integration minus dy, so you are getting e to the power minus y. And now the solution. So the solution is what is the condition? X into integrating factor e to the power minus y, this is equals to right hand side, that means y plus 1 into e to the power minus y dy plus c. Okay, or x e to the power minus y, this is equals to, you can break this integration, so y e to the power minus y dy plus integration e to the power minus y dy plus c. Okay, now y e to the power minus y, so let's apply uv formula. So you are getting y integration e to the power minus y dy. Okay, and minus integration derivative of the first function, that means 1, integration of the second function, so e to the power minus y integration is e to the power minus y dy. Okay, plus here the integration will be minus e to the power y. So minus e to the power minus y plus c. Okay, so this is equals to, the integration will be minus y e to the power minus y, and this integration is, this is minus minus plus, and e to the power minus y integration is minus e to the power minus y. So again minus e to the power minus y, and this is e to the power minus y plus c. Okay, so what are you getting? Here if I take common e to the power minus y, if I take common e to the power minus y, so you are getting minus e to the power minus y is common, so y plus 2, yes or no, plus c. Okay, y plus 2 plus c. Okay, now from here let's calculate it. You can write that x e to the power minus y, this is equals to minus e to the power minus y into y plus 2 plus c. Let's divide by e to the power minus y. So this will be x is equals to minus y plus 2 plus c e to the power y. Clear? Okay, so you can write x plus y plus 2, this is equals to c e to the power, c e to the power y, c e to the power y, and this is your, which is the required solution. Required solution. So in this way you can solve this type of problems, first order linear differential equation. Now try to solve the exercise problems of your textbook, Daspal textbook. Okay, there are so many problems in Daspal exercise. Try to solve all the questions. If you have any doubt, you can ask me on my WhatsApp number. Thank you so much.